So thanks for the intro. That was great. Yeah, as she said, I spent about the past year or so consulting for Google. For the past couple years, I've been writing for Envision. So if you read their design blog, maybe you read some of my stuff. What I'm doing, what I'm working on is, like she said, a book called Designing Intelligence. The goal of this is to teach people a lot about, these are influencers, by the way. These are people that have helped me put it together. So Nandini Stocker, head of voice at Google. Hugh Dubberly, who is a co-creator of Apple's Knowledge Navigator way back in the day. So that was really cool. And then a whole handful of other people that are really good at what they do. What this is about. So what I'm going for here is a design thinking approach to automated intelligence services in an era that's going to become ambient computing, right? IoT, everything's becoming connected. We're tracking data on everything. And I also believe that because of the technologies and the way they're advancing, we're going to get into a world where we're going to be talking to a lot of these things. We're going to be able to keep our phone in our pockets, and in terms of ambient computing, we can talk to the machine. It will track us regularly. It won't have to have as many inputs from buttons and screens, things like that. I think we'll still have screens. It's still a relevant skill. But I think we'll see more and more interactions that are going conversationally. So we'll kind of talk through this. We'll talk through why we've gotten to this point and what's happening kind of now. Then we'll go through conversation design and how, like, that's going to play a role within these systems. And then towards the end, we'll wrap it up with the future and where things are headed. So we've learned how to design these things properly. How do we make a product that is going to last a long time? So yes, we'll start off with data technology and how they've kind of worked together to evolve us as a species. And we can think of data as a piece of information that is stored for later analysis, later purposes of knowledge. And there are 3 or 4 major catalysts that have helped us in an evolutionary purpose. That is the reach of data, how far it can go, the specificity of data, the context of the conversation, right? Like the things that I can say to someone one-on-one, I know the history with that person, I know a bunch of different things. There's context to all of our interactions. The permanence of it, so how long does it last? Is it something where when I'm speaking to you, it's ephemeral, it's literally gone as soon as it's out my mouth? Or is it recorded, which more and more we're seeing recorded, right? And then the speed, how fast can this information travel? So I'm going to walk you through kind of different stages of this, and then we'll talk about the bigger picture here. We started off one-to-one communication. Millions and millions of years ago, language was invented, and it's one-to-one communication. This is the first time where essentially language is like Bluetooth for the brain. It lets us send thoughts, data, knowledge, whatever we want, to another person without having to do anything. It's seamless, right? We started to be able to trade ideas at this point. Then, as time goes on, we get into villages, we get into larger communities. In these areas, we may have town halls, we might have posters going up, things like that. But still, at this point, the reach is not very far, right? Small groups of people, very contained space. The specificity is much higher at this point in time because we're able to kind of keep in with context pretty well. And as time, that changes. But one of the biggest changes in terms of permanence was the Gutenberg press. This was the first time that we were recording information, data. At this point, it was the Bible, right? It was the first thing to get pressed. And things were more permanent. So at this point in time and years going on, we could then look back and we could read other people's opinions. We could learn in a much faster manner than way back when it was all oral stories, right? Things were recorded, so anyone could go find that knowledge if they wanted to. Then we get into telecommunications, the root of tele, long distance, far reaching. We're reaching around the globe at this point. Things are more and more permanent as they get recorded. But the actual specificity of the context starts to go down, right? We get into the internet, and now we're going across the world. Specificity has pretty much plummeted at this point, right? It's just something that's sitting out on a web page anyone can find. We don't have that specificity of context. It is maybe self-serving to an extent, but it's very low. More recently, we got into targeting. So now we can take all these groups of people. We can send a more specific message based on demographic information or behavioral data, whatever that is. And now with automation, we're getting to the point where we can interact at scale, one-to-one with people. So if you look at like a graph of this, it might look something similar to this, where you see over time the specificity of it, it dropped pretty dramatically all through telecommunications and the internet. But everything else, the reach, the permanence, the speed of it was rising rapidly. And so what this has done is this has allowed us to evolve faster because we have data. We literally are recording the world. We're recording history every day when we interact with our machines now. Versus long, long time ago, like I said, it was all storytelling by oral process, right? It took longer, it took generations to learn and pass down, versus now it's instant across the world. Anybody with an opinion, it's out there. And so how has this played out in terms of evolving technology? We can look at a short history of automation. The early automation starts with the cotton gin, 1780, the Industrial Revolution. And in the past 200 years or so, we've came pretty far, right? The cotton gin, the census calculator, to now Amazon collaborative filtering, or the recommendation engine, and Google search. It's pretty far. But if you consider how fast we've come just since the early 2000s, you're looking at an incredible difference. We're seeing paradigms that are so fast, we don't even really understand what's going on anymore. No offense to any of you. We haven't experienced this before, right? It's kind of crazy. Why is conversation going to play a big role in these systems? That's, I think, a question a lot of people are wondering, is why is this coming up so fast? If you think about human-computer interaction, the first interactions were binary. It was punch cards. We had to speak the computer's language in a very strange manner. It was not something most people picked up. It was very technical, not easy. The 60s and 70s come around, we get into command line interfaces, assembly languages. So we're able to start to speak to the computer a little easier, but it's definitely not English. It's not a one-to-one communication we fully understand at scale. But then you get into the late 70s, the early 80s, we get into graphical interfaces, and we have a mouse now that we can point and click. So now we have to learn the system, but we don't have to learn the language. So it's much easier for people to interact with. We see a mass consumer audience take off at this point, right? More recently, we're into touches and swipes and pinches, more natural interfaces. But the reason why conversation is going to be the next is because voice, language, conversation, it's innate to our human being. We don't have to learn a system. The system has learned us. And so we can just conversate or have a conversation with it, tell it what we need, it'll figure it out. Last year, over 20% of searches were through voice at Google. And of those people that were doing it, 60% had just adopted in that year. So we're seeing this grow at a very rapid pace because it's just intuitive. It's the most intuitive interface that you could have. So now I'm going to take a second to walk through how we understand language a bit. This is not necessarily going to maybe output your design, but it's something that maybe you can have conversations with developers a little easier, help you out there. So language essentially is just packages of symbols, right? A letter is just a symbol. It's a character. If I were to abstract this letter, any of these letters, make it huge, you wouldn't really know what it was. You'd see the form of it. You might see a line. But we learn to understand letters based on the characteristics of its symbol, right? So we have here, what would anyone guess? If I could get like a volunteer, help me out here. Right? Bunch, right? So we know like a basic form. We start to see things. If I give you this much, you kind of know what it is, right? Or you think you do, but it's actually an M. Okay, so we go through this, we learn these, and over time, we use what's called a recursive strategy to interpret these things. We see the arches, we see the different forms of it, and then we learn. And essentially what recursive strategy means is that we think ahead. We see these different points and we make guesses, and if we're wrong, then we go backwards and fix it. But typically from our experience, we can predict things at a certain point. And once you learn the form of that letter, you can then recognize it in any other different shape. It doesn't matter. Words are just a group of those letters put together to make meaning. It could be an audible sound, it could be text. However, you don't really need to know the words to be able to read it, right? You don't have to see it in order. So most of you could probably guess what most of these words are. But you go to the next page, and it's put together, you could read it that way too, right? So then, well, what's a sentence, right? It's kind of crazy that we're thinking of this. Like, This is so innate to us that we make games out of it, right? Think of Wheel of Fortune. We spend time enjoying guessing letters and filling in sentences, right? But the crazy part about language is the vastness of it. This is probably like the simplest way that you could create an equation for a sentence. This is by language expert Steven Pinker. In his book, The Language Instinct, he breaks it down like this. And if you think about a sentence, essentially it's a subject and a predicate, a noun and a verb, which broken down needs a few more directions in order to make a fully meaningful sentence. But it's not a whole lot. You can make a sentence out of 5 words, really. However, when you consider the amount of words that we have, language is what he calls a combinatorial technology. So we have this equation, we can plug in anything in there to make sense. And we've spelt something. But if you think about the amount of determiners we have, the amount of nouns and verbs we have, if you were to actually try to mathematically figure out how many sentences you could make in the English language, it's somewhere around 46 quadrillion, 240 trillion. That's more than anyone's ever going to think of, right? Even if you cut that in 20%, there's no way that you're going to fill that in by hand, right? This is something that we have to create these automated systems to think through in the way that humans do, and it's not an easy thing. But we're seeing, like from Google, natural language processing, the ability to understand our language and print it out into text is at 95% recognition, which is very similar to human. Okay, so now we know a little bit about language. How do we give a personality to these things, right? Because people are going to innately do what we call anthropomorphize, which is put a personality into the system for us. So that's an opportunity for us to control the experience, right? Make it more enjoyable, make it easier to interact with. First, we'll talk about defining voice. I have a lot of different points in this, and actually afterwards, if you're interested more in this, feel free to come up to me because this is pretty high level. But if we have a text-based system, all of these things apply, right? People are like, well, how do you put a personality into text? And say, well, okay, as an English minor, they teach you in English how to put a voice into your writing, right? The things that really make that are like the word choice, the content choice itself, the punctuation, and the grammar. And that also plays into audio, so that will give us a baseline, right? That's something that we figure out who this person is. We can typically tell like socioeconomic status and probably a little bit about where they're from, things like that. But then when you put in audio, it's a whole nother level. At that point, we can typically tell someone's sex, right? And there's different data points that we get the emotions of this and the different intentions of this through audio that we can't get as well through text. So those are things that affect the audio voice. But we can look like, for example, someone from the north versus someone from the south. Simple word changes, right? Can I get a pop versus can I get a Coke? Maybe y'all, maybe you, right? Like simple differences. Words are a little bit shorter, maybe it's blended through. We can tell that characters are created by their voice, the words we use. Someone that's uneducated might speak like this versus someone who's well-educated might have a larger vocabulary, and they can create things that are much cleaner to someone that understands it, right? And then the same with happy versus grumpy, right? Someone that's happy is probably a little bit more optimistic versus someone who's grumpy is a little more pessimistic. There's different points in conversation that bring these things to life and define what the personality is and how they're affecting the user. And then how do we think about character development? So if I were to tell you, like, what is the best absolute personality to install in something, data will actually tell you that it's a male with a low-pitched voice that doesn't change much because it's the easiest to pick up. However, we do not want to skew people's perception of the world here, right? So you need to think through what fits your business and what fits your product. To think of character development, we can look more into popular culture. If you look at how it's evolved over time, back in the 90s, you have shows like Friends and Seinfeld and Everybody Loves Raymond. But if we look at these, we can see that in the 90s, the popular culture had painted the popular personality to be a white male of a patriarch family, right? Nowadays, we see shows like Modern Family, Blackish, and Jane the Virgin. People need these different views of the world in order to understand different perspectives. When we're creating personalities, we need to keep this in mind, okay? You might be driving for a business KPI. You might be trying to get more money. So maybe your boss is putting pressure on you to do things as most accepted at scale. What I would push you to do is figure out ways to create experiences that will be enjoyable to your users and relate that back to your boss in a way that proves that we can achieve his KPIs by doing it the right way. Then it comes to how do we actually design these conversations. So some conversation basics. First things you do in a conversation is that you need to initiate, right? We need to say hello. We need to listen. We need to understand the context, and there are ways of checking this through. And then you need to respond. So when it comes to initiating conversation, mostly we're working with trigger words here, right? Okay, Google, hello, Siri, whatever you want to say, hey, Siri, and anything with the echo, right? Trigger words are the way that we're probably going to initiate conversation with users, or have them initiate with us, suppose. Active listening. This is one that I think a lot of conversational interfaces get wrong. So when it comes to active listening, there's a point to this where a lot of bots that are working out right now, they grab information that gets input and they automatically respond. People don't work like that though, right? We don't text in walls of text often, we're texting in bubbles, right? And so if you grab the first one, they maybe don't even have their complete idea put together, right? Or if you think of sentences, so this might be an ideal sentence, right? If you're gonna book a flight, I need a round-trip plane ticket from San Francisco, California to Honolulu, Hawaii for one adult from January 31st, 2017 to February 7th, 2017. No one in your life has ever said that to you, right? They say, I want to book a flight to Hawaii, right? This is how people speak. So we need to listen, and we need to push them. This little indicator sign that we get at the bottom of text messages or any other time that things are waiting, that's how you show that you're listening. This could be an input. I want to book a flight to Hawaii. The response is, I can get you a flight to Hawaii, right? I'm listening. I heard that you said Hawaii. I'm reflecting it back to you. Which island were you thinking, right? Because actually, you can't just book a flight to Hawaii. There are 7 different airports. How do you get that figured out? I'm not sure. So if we consider each of these a bubble, I'm not sure. Let's go to Maui. See, so what happened is, as they're typing, and just as things get entered, you throw up that sign, show that it's listening. Give the user another second or two to finish their thought. Don't actually take that yet. As soon as everything has been stopped and it's 1 or 2 seconds post, you grab it and you read it and you analyze it, right? And when it comes to responding, when we're creating responses, when we're writing for a conversational experience, we need to consider quantity, relevance, and clarity, right? Quality comes in the sense of, or quantity comes in the sense of nobody, like I just mentioned, is going to read those long messages. We have marketing sites. We have all that stuff if they want to go check it out. Nobody reads those anyway, right? You don't want to make it again, okay? So keep the quantity down. We're typically looking at like 250 characters around there, enough that you can put in something meaningful, direct the action, and keep them going. Relevance, so it has to be on topic. If we're walking down the street, my friend turns and hits me on the shoulder and says, did you see that guy just got hit by a truck? And I'm like, yo, Candy Crush, what's up? Right? They're going to be like, what are you even talking about, man? This just happened. You got to keep it relevant to the conversation. So what is happening as you're listening? Respond in context. And that's going to be the hardest part, but there are smart ways of doing that. Clarity. This is something that I try to work people through. And at first, writing is kind of hard. But it actually gets really easy if you try to just say it out loud. So clarity comes in the sense of, is this readable by someone? Is it really, am I going to stumble on words? Do the words make sense to the audience I'm speaking to, right? If I start talking about machine learning and all this stuff to my family back home, it's completely over their head, right? So I have to use different words, clarity. And so now we've kind of walked through the steps. How do we create these things? How do we bring them to life? This is the process that I use. I found very successful, and that is create a persona, write it, condense it, prototype, build, and then we'll talk about this, but we're going to call it perpetual iteration. Okay, so one, we're going to build a persona. The persona is the new design style guide, okay? Instead of giving people a palette of colors and fonts, we're going to give them a persona that describes this character, whatever we've designed, It's going to tell them how this person will react in different situations and what their range and their pitch and their volume and all these things on a scale. So if we're going to make one for Batman, it might look kind of like this, right? So you give him a little backstory, a little bit, emotion. You define where he sits on the voice scale, the audible voice scale. Maybe give him some things. And this is a shortened version. Maybe you get into like Batman would react this way if Joker was chasing him, and Batman would this way if Spider-Man was chasing him, right? Because they do that now. Next, we're going to write. Writing, I think, is the part where everyone gets stuck, first of all, because a lot of us are designers, we're not necessarily writers, right? And so it's a new experience, and sometimes it's intimidating to get into. What I always tell everyone is to focus on one flow at a time. A lot of people want to just start writing everything. Pick one track that you're going to work on. So maybe it's book a flight in that sense, right? And start working down that track. Once you've done that, then think of different ways that people might respond in there. And then maybe go over to a new track. Then condense it. So you're going to have a lot, and that's fine. The goal with good writing, just like good design, is that you're going to try a lot of different things. Wipe the stuff that's not meaningful. We just need the most meaningful words out of everything. So take 3 paragraphs, shrink it down to 3 sentences, right? Then prototype. So I'm going to tell you the easiest way to prototype, and this might blow your mind because I know there's a lot of people trying to get into bot templates and things like that. The easiest way to prototype a conversation is to have the conversation. Go write it down on card. Take steps of here's the user output and here's the bot output. Make those cards, hand it to someone else, walk through the conversation. Just like sketching and design, we don't want to go too high fidelity before we've cracked like the base level all right. Then you can build it, take it into high fidelity, put it into a bot template, prototype it, and then we iterate. So I'm not trying to stress you out, but designing conversation is not easy. It's not a launch and release like 6 months later again. It's something where you're going to be getting data. You're going to try to make a conversation. It's not going to happen. It's going to get real close, but it's going to take you a few months to get the data in there, to see what people are saying, to adjust the conversation and the direction of it. So you got to think of it as like you're launching a beta essentially for a few months. And if you think about it that way, it's not so different. But it is a lot of work for a while after you launch because of all the data you'll get. So now we've learned how to work through a conversation, design it, bring it to life. How does this fit into a system, right? Because essentially with these automated systems, it's an input and an output. The input goes in, it gets processed, that is the knowledge base, the intelligence, and then it serves something, a service of whether that's changing the temperature of your nest or turning on your kitchen lights, whatever that is, there's an output. But nowadays, with everything that's connected, we could literally just push it wherever we want. We get in this tangled mess, we're talking with our bosses about what's the most effective, what's the most efficient, what's going to earn us more money, and they just want to connect everything because they just want more money and everything must mean more money, right? We need to actually make meaningful experiences and meaningful ecosystems, right? There was the age of, okay, I need a website, and then everyone needed an app, and then everyone needed a mobile website and a mobile website app, right? They're going to come and say, we need a chatbot. Maybe you don't need the chatbot in the sense of a conversational interface like a messaging platform. Maybe it's in a different form where, oops, take them out. But maybe it's like your Google Home and your hands-free, right? So where are these good to use? It's places where a conversation is top of mind. So if I'm interacting with something and it's information that I can get, you probably don't want to have someone work through their tax records. Just ask them that, right? You want to plan that ahead of time. So maybe that's something you process in the system. Sometimes it's just easier to say things. We've all had conversations with friends where we're texting back and forth. It's getting nowhere. It's just easier to pick up the phone and call, right? These kinds of situations, conversation's great for. And then the last is when it's hand-free. So maybe you want to play with the kids, or maybe you're cooking, or whatever it is. Maybe you're in a pottery class. You can't use your hands, or you just don't want to take the time away from that. These are great places and interactions to use conversation. There we go. So there they are. So you might use your phone when you're exiting the office, and it's in your pocket. You have your Bluetooth headphones in, and you might direct it to start the car, or to send a text home to remind you, or to someone else to start the oven. And then you might have your thermostat turn up because you're headed home and you need it to be warm. Or it could be your voice platform. So now you're home, you've cooked dinner, you need to turn your thermostat down, you need to turn off your oven, and you need to turn on your TV because you're ready to eat and watch while you're eating some food. Or it could just be your car where you walk in and you say, hey, I'm in my Tesla, take me home, right? Very simple conversation points, not worth getting out a phone and pushing buttons. And where's this all headed? So I talked on this for just a split second in the very beginning, but the growth factors that have led us to this point are data and mass collection, which we walked through at the very beginning. Also, processing power and storage capacity. So the speed of computers and how much information they're even able to hold. And then the algorithmic efficiency of all of this, right? Because we'll walk through a little bit, but we'll talk about Moore's Law and the limits of those, right? First, let's pull it way back. Let's think about, like I did a little bit earlier, the time periods, the eras that we've experienced over time. So if we look at societal evolution, millions and millions of years ago, we were a hunter-gatherer society. 8,000 years ago, so very, very short relative, right? 8,000 years ago, we were in the agrarian area where we were farming to live. And then just within the past 240 years or so, we have entered the industrial era. So if you look at just this, you can see that we're scaling pretty exponentially, right? Knowledge, right, like we talked about earlier, data, the way we share things, the evolution of technologies, it's getting very fast. If we look even within the industrial era, though, this most recent era, we can see that the paradigms are shrinking here as well. You have initially the steam era, which was about 120 years. Then you get into electricity, the electrical era, and that's about 80 years. And now, for the past 40 years or so, we've been in the computing era. Now we take one more trip into the computing era, we can see that it's even smaller. So we've gone from millions and millions of years to now we have these paradigms that are happening about every 2 years, right? And if we look at this way zoomed out, we can see that social development on a scale has been pretty much flatlined for most of the time until the Industrial Revolution, where it took off. And why is this? So when it comes to processing power, it has to do with the number of transistors that are on a chip and how much data, how much information we can push through those all at the same time. Gordon Moore, back in 1965 in Electronics magazine, stated that at this point, the amount of computing that you can get on one chip is doubling it's going by a factor of 2 every year. It's getting cheaper and cheaper, right? What he didn't know, he predicted this would happen for 10 years or so. What he didn't know is that it would go on for nearly 50 and still continue. So we're seeing right now the most chips or the most transistors on a chip right now are over 7.2 billion, which is pretty crazy, right? There are said to be limits to Moore's Law, and you can't really argue that until maybe we get into nanotechnology or something. But then we get into something different, something that Ray Kurzweil deemed as the law of accelerating returns, which has less to do with the actual physics of a device and more to do with the mathematics and the efficiency of things. His theory, essentially, the law of accelerating returns, says that as things become more orderly, we are able to speed up. So go back to the thoughts on data. We can also see that as we organize things and recorded them, it's easier to keep track of them and organize them in a meaningful way. We have these huge databases of information now. And because everything's so organized, we can just grab chunks of it in a meaningful manner and build new things. So what he's saying essentially is that as organization increases, so does the speed of acceleration. And there is no physical upper limit to this, right? So what we're about to experience is the next industrial revolution. It will be that AI is essentially the new electricity, and data is the new oil for that system, right? So how can this go well? Because I think, honestly, I'm pretty optimistic about this, and I hope that it does go well. Let's talk about some things. Automation can make the future much more safe in the sense of, think of smart cars, right? Driverless cars. If you look, okay, the average consumer drives about 12,000 miles a year, right? My parents own a body shop, trust me. Maybe they drive 60 years in their life, right? We'll give them 60 years. 60 times 12 is 720,000, right, miles. And that's not even 1 million, but we'll round it up to 1 million to make it easy. Tesla, in 15 years, has already driven over 3 billion miles, right? So that little car right there represents your lifetime worth of driving experience, and this big pool of cars represents the amount of knowledge that Tesla has in their vehicles, right? At a certain point, it will become a matter of public safety that we have self-driving cars, and that's a good thing. That's a lot less deaths, right? It can make things more inclusive. So here, what we see is a program called Nadia by Soul Machines. Nadia is a 3D rendering. The person who made her also did the graphics in King Kong and Avatar. What they're doing is they've created a system for New Zealand disability information system, I believe is what it is, where it's tough for people with disabilities to navigate these systems sometimes. Like maybe they have memory problems and they're unable to keep track of where they are on the steps over the phone, things like that. They've created this system where it is a bot, a chat bot, that prints it out for you, speaks it as well, so you can hear it, and gives you a visual of the person that's speaking. So as we spoke earlier, the facial features, the words that we're saying can be read by the lips and then spoken, and it just makes it easier to understand, right? It can be more meaningful. Once we get away from heads-down computing all the time, we have more time to have conversations with other people and get out into the real world and not be stuck 6 hours a day in our phones, right? However, it can also go bad, and we should consider that, right? Depending on how it plays out and whose hands it's in. So some examples of when it goes bad is maybe when it skews perception, right? I had just mentioned that we're in our phones, we're on the internet 6 hours a day. That is by the Kleiner-Perkins study, data release, one of the biggest internet studies every year. And the problem with that is that we're in a new mode of media. We're in a new era of media. If you think about traditional media, right, way back maybe in the 70s, there were only a certain number of newspapers. There were only a certain number of television shows and broadcasts that could get your news from. So we saw kind of a bell curve in terms of the knowledge base that our country had, right, or people around the world too. However, with modern media, it's based on different things. We live in filter bubbles, and it's based on the attention the engagement that we have with these data points, essentially, right? So what this has done is it's skewed people's perception, because when you're in 6 hours a day on the internet and you're living in a filter bubble that is based on someone making profit off of your attention, it's not a good system, right? There are things that need to be done here. We also see systemic bias. So if you're thinking about algorithms, let's say we're building a credit e-score. Would you ask someone for their race in order to create a credit score? Yes or no? No? Probably not. Gotcha. Probably not, right? Because we see that this is clearly racist. However, would you ask them for their zip code? Because typically, zip codes can tell a lot about us, right? And zip codes are very commonly taken into algorithms and affect us. So if you think about those credit scores that then skew us on some scale that is rendered by a machine, has no humanity, that credit score then goes into our ability to get an education, to get a home, to get insurance, right? So we're creating algorithms that I truly believe were created with the best intentions in mind, but that are skewed and biased by the people that have built them. And then you want to talk about job elimination. It's a thing. It's going to happen at some point. I do believe there will be new jobs, and we'll figure it out, but it's definitely going to happen at some point. And how do we bridge that gap? Because right now, if you're looking at what this line is the GDP, and this is the employment to population ratio. And if we're looking at this, we can see the automation kind of really started to take off in the early 2000s, right? Profits were skyrocketing because automation is nearly a perfect capitalistic pursuit. But we weren't hiring as many people. And we weren't necessarily letting people go at this point because it's hard to lay off mass amount of staff at once, right? It's not something that bosses enjoy doing, and it's at scale very tough. But then we had the Great Recession. The market dropped. It gave employers a great reason to let people go. And as we see, our GDP has steadied out and recovered, but our employment has dropped. Those people that lost their jobs, a lot of them haven't got their jobs back. We're seeing this play out in politics, not only here, but across the world, over in Europe with Brexit, right? We want nationalists, people that are standard to the core values. Well, the values are different nowadays, and we're seeing it because of these disparities. But like I was saying, it's nearly a perfect capitalistic pursuit. The work being done by these machines is nearly 30 times. And if you look at the work versus the cost analysis, you can see that humans are clearly more costly over time as well. So there will be issues, and we're already seeing like Coin by JP Morgan last year. This is a financial legal document analysis system, and they replaced 360,000 hours worth of work last year. It's better for the bottom line, right? So what do we need to do moving forward? First, we need to increase data literacy. So a big part of why I'm writing this book is to help people understand these issues that are going on, and how to adjust to them and how to work with them. Because if we do this right, it can turn out really well. But we need data literate citizens who can not only help build these systems, but also speak to this publicly when they need to educate other people about it, or talk about it politically when it comes time to vote and regulate things, right? It can be done well. We also need equal opportunity by design. We talked about systemic biases in these systems. The only way you get rid of them is by hiring people that have those experiences in their lives. We look for an engineer based on their background, their degree, and their years of experience. We look for a designer because of their technique and their years of experience. Why would we not look for a staff that has years of experience in the thing we're trying to build? We need to discover and accelerate emerging markets. One of the biggest things we need in the system is competitors. If it becomes a point of monopoly with data, that's very dangerous. We need competitors to be pushing the boundaries. We need to help people grow local, sustainable businesses that when the big companies come in, their system's better than what the big company does at scale. Scaling is very tough. Doing it hyper-locally is even harder. So we need to help those people that are building these things accelerate. You need to regulate automation, right? So if it takes jobs, you're going to see a lot of things happen, right? You're going to see a loss of infrastructure money because we don't have taxes from employees. And if employees don't have money, they can't buy goods. Different things like that, right? It all adds up. If self-driving cars are going around, we don't need insurance for the individual. How do these things happen? We need to regulate it in a meaningful way. I think you definitely need to tax automation, right? For every job that it displaces, maybe you take a certain amount of taxes, and then that can be used to allocate universal basic resources, things like education and healthcare, and potentially income. Although I don't necessarily believe in basic income, because at that point you're giving money to everyone, which means you're giving it to the rich people as well. And maybe just making that disparity even larger. So I think a better outcome to this would maybe be like a reverse income tax. So if you're making a certain amount of money, you actually get paid on top of it to match what you need, right? I think there's a lot of things to be talked about, but I just want to bring this stuff to light so that as you're building these systems, just know that when you're listening, listen well. Learn what you can and help educate other people, right? Because this stuff's not going to change based on one person, no matter how charismatic you are. It's going to change by a bunch of people working together. We're at a point where our country is very, very well displaced on opposite ends of the spectrum, and we need to start working together again because this can get dangerous, right? Hopefully it all turns out really good, and I believe it will. I hope that also you learned a lot here. That's all I have. It's over. Okay, I can't put that in. Oh, designingintelligence.com. I can't believe it was available either.
Okay, so if I wanted to prototype a bot, a chat bot, what would I do? Like, where would I start? Is there a specific website that I should go to?
I think, can everyone hear me? I think
hold the microphone though for the recording.
Oh, for the people.
Yeah.
Okay. Okay. So I think that like everyone already has it built out of this to an extent. Okay, just hear me through, because I think what you're really doing is you're extending your business, right? So it's not necessarily that unless maybe your business is now a chatbot, right? At that point, I think that you just kind of build out the system to fit your business, though. Is what we're gonna base it on.
Basically asking about a tool. Is there a tool?
Oh, what tool specifically?
Yeah.
Oh, okay.
Like is there like an entry tool that I can go in and type in questions?
I think it depends what stage you're in of it, but like very intro stage, Like I said, paper, pencil on cards. Then you go to build it out a little higher fidelity. I think you can take it into a bot template. There are multiples out there. I mean, you could do Chat Fuel. You could do Motion.ai. One of my favorites that I actually worked with them a lot is Reply.ai. They're a little bit harder to work with. At this point, it's a little bit, you kind of got to have a dev background, but I think that they're an incredible tool, much more powerful than the other ones. The other ones are kind of like trying to build your business on an envisioned prototype, and that's just not realistic. You know?
Okay. Well, guys, thank you so much for coming out tonight. Thank you. I really, really appreciate it, Joe. You're awesome.